Good everyone, here I've got this question. An industry buys 200 grams of radioactive sample with a half-life of 5 years. How much of the radioactive sample will remain after 20 years? So here we know that this is a radioactive question. Okay, and when you talk of this radioactive, we say it's a simultaneous emission of radiations from unstable nucleus. Okay, then we also have half-life. When talk of half-life we say is the time taken for a radioactive substance to decay by half. Okay, so now in order for us to answer this one, first thing we need to apply the formula for the half-life. We talk of half-life, so say it's like this. Okay, half-life is equal to 3 over n, where this one here represents the half-life. Okay, then t here represents the total time, then n the number of half-lives. Okay, so now what they want is the amount of the sample that will remain after 20 years. So what will remain, will simply say we have n is equal to n initial, okay, and then half to the power n. Okay, where this n here represents the initial substance that you have been given. Then this one here we can put f. This one it represents the amount that will remain after the given sample has been decayed. So what will remain is represented by n this one. Then n this one, it represents the initial amount. This is the remaining amount. Then n here it represents the number of half-lives. So like in this case, we have been given the half-life here, it's 5. So 5 here represents the half-life. Then the total time that will take this element to decay by what you want to calculate here, it's what, 20 years. Okay, so 20 years, it is the total time. Then half-life here, it's what, 5. So just replace. Here we have where there is n, okay, where there is, or we can just make n subject of the formula. So before we can do that, let's just replace where there is 5, where there is half, half we replace by 5. So here we say 5 is equal to total time here, it's 20 over n. So when you have something like this and this, we are going to have 5n is equal to 20, then over 5 over 5. There will go. So our n here is equal to 4 half, okay, it's half lives. Okay, so this is the number of half-lives. So 4 represents here 4 half-lives. Okay, so now this 4 is the one that you're going to replace where there is n here. Then where there is this initial amount, we have this one which was purchased, okay, by the company or the industry. So we have this one here. So what to say, we just compute in the formula. N is equal to where there is this one, we say it's 200. Okay, 200. And then we have half here to the power 4. Okay, so having this, say n is equal to 200 times, so here 1 to the power 4, it will give us 1 over 2 to the power 4, it will give us 16. Okay, 2 to the power 4, it will give us 16. So we look for a number that can go in both. 16, how many times can 16 go into 200? So here we are saying that here we simply divide this one into this. You can use a calculator. So using a calculator here, this into this, we are going to have 12.5 gram. So this one will remain after 20 years. So this is the amount that will remain. Now, if I thought the question was like how much of the radioactive substance will decay after that one, so this is what will remain. Would have just find the difference from what this one, so would have just subtracted, and the one that we are going to find, that is what will decay. So as for this question, they just wanted us to calculate how much will remain after 20 years, which is 12.5 gram. Thank you very much.